Good afternoon, all. Basically, we are working in data science project. Different kind of projects we have worked on. Different kind of data we have handled. Different ways by which the project deployment is done. So I'll be talking all many different steps are there that we have to consider. But depend upon the type of project we have to work in that. So all I have collaborated together in this particular session, and we'll talk about that in detail. Why it's required, what's the application of it, how do we make use of this particular technique specifically here in it, starting from the project definition till the deployment. What are the different steps are there that we have to consider, we have to understand, and which the knowledge of which technology we require, that also we'll talk about. Okay, I'm not having any special I'm not talking about any special programming language here. You can choose any programming language, but the common ideas which are used in the data science project development that we'll be talking, because it's not like I'm designing a web page and I require HTML and then I will be making use of some drag and drop tools to design that. It's not that much simple. We have to take care of different kind of processes, different kind of applications which we required at various stages of development there. Okay, so let's continue. What exactly is there? So in first few minutes, we'll talk about data science and the brain of data science, that is machine learning, and then we'll talk about the detailed development process that we used to handle. And maybe if you want to work on data science, you know, to perform the similar kind of operations for the same. Okay, what is data science basically? See, data science is like, it's a interdisciplinary field. I mean, it's a combination of multiple disciplines here, which uses the scientific methods, processes, algorithm, systems to extract the knowledge, insight from structured and unstructured data. Okay, two things I mentioned here: structured and unstructured data. Both are there. That also we'll talk about, and apply the knowledge and actionable insights from the data across the broad range of application domains. So wherever the data is collected, wherever. So though it's wherever, I think everywhere the data is collected online. And from last 1.5 years, we have seen almost everything is made online, and because of that, huge amount of data is getting collected. So we'll be performing operation on that and extracting the knowledge, and then performing some actions or create some actionable insights from the same based on the given data there. Fine. So that's what data science actually does. So data science is connected with data mining, machine learning, and big data. So three common big areas are there under data science, which are data mining. Data mining means converting the data into information format. Okay, we extract the information only. Data machine learning, converting data into action format. That is called as machine learning. And the big data, which is like we are having huge amount of data, and when you are handling huge amount of data, it will be very difficult to handle the data, huge data, with the help of traditional computing systems. So in such cases, we need to apply the big data analytics technologies. That's also the part of data science. Okay, and it's multidisciplinary, not only data input, data analysis, and generated results. It's not like that. It is a huge number of disciplines, different branches are then under data science, which are required at various stages of development. See, the science is always multidisciplinary. If you talk about general science or social science or any other science, it's already multiple disciplines. Data science also having multiple disciplines there, and all of their knowledge will be required at various stages of development in the actual application areas. And these principles are applicable to all, whether you use the big data or the small data. So first thing is to note that whenever you are developing the algorithms of data science, project of data science, we require the knowledge of multiple different fields, because the application of data science is not lying within a specific area. We require the knowledge from almost all, wherever you're working currently. So like science, engineering, economics, politics, finance, education, automobile, manufacturing, sales, advertising, like all, everywhere data is collected, and there we can apply the data science. But remember, in general, there are three different areas which are present under the data science. So what knowledge we require? It's not like I am a computer developer, I am a software developer, and I'll be a good data scientist, or I'll be a person who will be developing best data science projects here. It's not always like that. So computer science is okay. We require the knowledge of computer science, computer applications, pattern recognition techniques under it, visualization, data warehousing, HPC, databases, artificial intelligence, that knowledge we require. But it is just 50%. Along with that, another 50% knowledge we require is mathematics, maths, and the statistics. Okay, mathematics and statistics. So these two main fields are there, which are also the part of data science. We have to use the data and we have to perform some mathematical operations on it. So we need to know the knowledge of mathematics. We have to understand the knowledge of, we have to gain the knowledge of statistics also, probability also, linear algebra, which are present under the statistics and mathematics. Okay, so it's a part of it. So just make sure that whenever you're doing the project, so we need to mention, remember that it's not only the part of computer science, we require understanding of mathematics and statistics also. Now, see the common requirements of data science. It's just shown in this beautiful diagram. I don't know who have created that. Okay. So this is the best idea by which you can see the data science from multiple angles here. See, three fields are there. We require domain knowledge because the project that we do, that's taken from the client. So client gives us the idea or basically their requirements there. And based on that, they identify. So that client can be from automobile sector. The client can be from the sales sector, advertising sector, digital and marketing sector, or he can be from the web application development also. He can be from any other sector also, politics, education, finance, economics, like anything. So that data we require. So the data which you are going to handle, we require to know the domain knowledge of it. What exactly the data is important, or what exact data meaning is there, business meaning, how they do business, how they collect data, what's the meaning of data, what's the measurement of data. Even in healthcare also, lot many data sets are available. A lot many projects are now getting done in data science application design. So for healthcare also, we need to understand that data. Domain knowledge is required. First thing. Second, we require a computer science knowledge. That's what we already having. But what are the core data science knowledge we require? Science knowledge we require is database languages like SQL, Hadoop, SQL for structured database application, Hadoop for big data applications. Depends what kind of projects we are currently handling with. Then data governance, data pre-processing, data validation, data infrastructure. So operations related with the data that will be done under, that will be required under the computer science. And the third part is, as I already told, mathematical and statistical aptitude. This one, okay, where we require statistical knowledge, mathematics, designing methods, or fitting tuning models. And important thing is to know that we require the knowledge of programming languages. So the common data science is programmed using two main languages, Python, R. Even it can be coded in JavaScript also. I mean, some more small languages also present, but the world of data science maximum driven by the Python, and then it will go to R. Fine. So these are the basic requirements are there for data science project. Means we need to understand that it's not like someone has given me data set and you will work directly on that. But see, domain knowledge, your mathematical aptitude, and your computer science knowledge, that's what we require. The combinations of all will be having the data science here. And along with that, you can see machine learning is name mentioned over here. Machine learning is the brain of data science application development, because whatever task you do, whatever applications, operation you have to do, they are controlled by the machine learning algorithm which are using in the data science. We'll talk about that, and then we will see how different machine learning technique can be applied in data science development here. Okay, so these are the common requirements of it. Now, this thing that we have to follow. Maybe if you know software engineering, maybe if you heard, it's a theory subject basically. That's why we don't care of it. Okay, so software engineering basically tells us the systematic idea of project development and deployment also. Testing, like many steps are there. So using these ideas, data science application development is also done. There are 7 different steps present in life cycle. See, it's given as a cycle. It's a cycle. It's not like we are having a waterfall model. We start and we end till deployment. It's a cycle. Why? Because it is automated learning process which is involved into data science. When the last step is over, then we'll again start from the first. Many cases. So 7 steps I mentioned over here. We'll talk about that 7 steps also, step by step. What's the requirement of it? Why do we require it? And what algorithms are required at various stages of development? Yes, we'll start with the first, business understanding, which is mentioned over here. So data will come from many businesses. You're having a core idea in mind. I want to work on this kind of data. Okay, I want to work on this kind of data. So we'll be having the data for the respective business there to understand how this business works, how the data is getting collected, okay, and what's the meaning of that data. It's very important to note. For example, if data is from the other countries, they are given some values of liquid measurement. So basically, some countries measure the liquid in gallons, we measure in liters. They measure distance in miles, we measure distance in kilometers. They measure the weight in pounds, we measure weight in kilograms. Like, your different units are there. So we have to understand that data, in what format that very important to know the data and business understanding will be there. At second stage, you need to clean stage, which is present in the data science development, is data cleaning. We'll talk about that, how exactly is there, because if the data is full data, make it useful, or if sometimes missing data is missing, so we have to get that data. Okay, so mining, sorry, first mining and then cleaning is there. Mining is converting data into information, means information is useful data, meaningful data, that we have to work it. We are going, then we'll clean the data. If data value is having some missing values, some garbage values, so we have to make the data available as per the requirement of it. Okay, that's what the third step required here, data cleaning that we do. Then at the fourth stage of development, we require the data exploration. We explore the data. I'll talk about that also. Which are the different techniques present in data exploration, why they are required. Data exploration, we explore the data. So to do this one, some statistical technique and some visualization techniques are also present that we need to use. Then at step number 5, feature engineering. Feature engineering is identifying the exact features, exact parameter which will perfectly create your model. That is what we call as feature engineering. Under that also, again, multiple steps are there that we have to take in consideration for data science development. And sixth number, this sixth number is the, again, brain of data science development. That is what we call as predictive modeling. Predictive modeling. The data that we get input, all the tasks are done, and basically most of the data science project which are created, they are based on the, we are having previous data. With the help of previous data, you perform operation, we build a model, and we do the predictive modeling. We use that data for predictions ahead of it. Okay, it was happened in past, now what will happen in future? Like, or robotic applications, one of the best application of the predictive modeling. We predict it, yes, pattern what will be present ahead that we can find. That's called as predictive modeling. Then at seventh stage is data visualization. Data visualization can be done pre-modeling and post-modeling also. So whatever you have created, its insights are easily known, easily found or not. Or if something is missing, that we can completely analyze with the help of the data visualization. We'll talk about that also, why the data visualization is required. And after that, we'll go to the, again, first time, it's a cycle there actually. Rebuilding, just like gaining experience and performing operations again. Gain experience, perform operation again. Now, for example, the decision that we have taken this year may be not correct. Next year we'll get more better decision, because we have learned from your experiences. The same kind of algorithms of machine learning based algorithms are used as the brain of data science project development, and because of that, algorithm get refined by itself, it will learn by itself, then automatically the project will change every time when you run it multiple number of times. It will gain experience, and will perform the operations there. This is the common idea, common methods which are used in data science life cycle. But under it also, very small steps are there. Why, when, and how these steps are required, that also we'll talk about. Okay, before that, let's see a few of the case studies, how exactly data science applications are present. Okay, so some of the applications are mentioned on this slide. Some are mentioned, thousands, lakhs of applications are there. In our day-to-day life also, we see that. Some of the sectors I mentioned over here: healthcare, transport, finance, banking, manufacturing, e-commerce. Few of them are mentioned. Now you can see here in the healthcare sector, you can see medical image analysis. For example, some images are taken, just like consider the current situation by using the scan, the chest scan. We can identify whether the patient is having COVID-19 or not. Like, I just want to find it, so I'll take that images, and based on that I can identify. Even drug discovery, bioinformatics, virtual assistants are the common example where the data is used, and based on that applications will be created. Or we'll go to transport, self-driving car. Yes, the car will be given training first, how to drive it, what are the different parameters are there, principles are there for driving. So it will be given as input, then the car will learn by itself and will try to drive by its own, like all. Or car monitoring system, or enhancing safety of passengers. So you can identify different parameters. With the help of it, we can put some valuable insights. With the help of it, the safety of passengers can be enhanced. So many different kind of things or transport can be done. Even if you see the applications of Google Map, they shows you at what particular time the person will reach to the destination. How they knows it? based on the traffic situation, based on the type of roads, based on the previous data where the passenger has traveled from the respective data, respective route, then how much time was required. Based on that, your predictions are done, and almost they are correct. That's what the prediction systems work. It's a part of data science, because previously created data will be used, and based on that, applications are created in transport, finance. Okay, so these factors are connected to you. That's why maybe they are useful for you. Customer segmentation, creating the groups of customers. Okay, these customers are separate, these are separate, these are separate. So based on that, we can decide a marketing strategy for this group of people. That may be possible. A strategic decision making, what to do, which product is in demand, which is not in demand. Like that analysis we can find, and based on that we can increase the production of the particular product, or we can decrease the production of particular product based on the particular features or that we identified. Risk analytics, okay, like this can be possible in finance. Even stock market prediction is also possible, that also we can do. Okay, it's present there. It will be in finance sectors. What was the price of stock of particular company yesterday or last week? What can be future? Like that we can identify. That is what we require the previous data for that. Okay, this is what simple application of data science. If you go to banking, fraud detection is one of the main application of it. Fraud detection. Okay, if something weird happens, for example, just can take an example that a particular person used to draw the amount from his bank account regularly and not more than 10,000. From last 6 years, you're drawing the same, but immediately, accidentally, we got a transaction of 50,000 rupees. So we can identify the fraud. This is a simple example I did, but there are many factors which are used. We can identify whether the fraud is there or not automatically. We don't have to take care of it manually. Okay, that we can do. Or credit risk modeling, whether we have to give credit card to this person or not, or whether you have to provide the loan to this person or not. That decision making can be done. Or customer lifetime value, we can identify that customer is retained, will be retaining, or what the expectation of customers are there. Based on that, what we can provide to them. These are automated decisions can be taken in banking. In manufacturing also, potential problems. So maintenance of a particular machine can be predicted with the help of these particular data science applications. Maintenance of different machines can be given as input. They need to identify the pattern. Based on that, predictions can be done. Monitoring system on machines can be created. Automated manufacturing units, they will perform the things automatically by their own without human intervention. Maintenance scheduling and anomaly detection. Anomaly means something weird situation happened. Indiscrepancies are there in the operation that can be identified with the help of data science application development. Or if you go to e-commerce, you can identify the consumers, their behaviors, and based on that, recommendations can be given to them. That's what recommendation systems can be created. Just like if you purchase something on Amazon's website, they show you suggestions frequently bought together. So this product and this product is get bought frequently together. How they identifies it? Again, there's a data science algorithm present behind it. Okay, analyzing reviews, like customer has given the reviews, but how much percentage of reviews are positive and how much are negative? That also you can find with the help of the applications. Even Twitter sentiment analysis, that can also be done. So like many such broad areas are there. Wherever the data is collected, we can use that data to do the predictive analytics of it with the help of data science. So you just can think of it. Yeah, I'm having this data. What can I do with this data? Can I use this data to perform some predictive analytics, or can I use this data to make some decisions out of it? That we can do. So many such applications, not only in these specific areas. You take any area, and based on that, we can perform the operation. Like just like I worked on one of the project of accident analysis. So of one of the automobile company, what they have done, they've identified the data of accident vehicles, the accident which happened with vehicles, along with the driver's information also. And based on, they have identified the perfect model by which the car should be modified. Okay, car should be modified. Should be sold to this kind of customers, and that's also one of the factors present over there to minimize the risk of accidents. That analysis was done. Even one more company which is working on the generator sets, and with the help of that, we have to identify the preventive maintenance when the next time maintenance is required, scheduled, or maybe in next week at this time system may fail. That we can identify prior to it. Like this kind of projects can be done. So you can take any kind of applications, you can make use of it. Even in digital marketing also, if some persons, any particular person will purchase this product or not. Okay, if it is purchasing, is most likely purchasing, then only will show you that particular product, will market that particular product. Like This kind of applications are there so that we can use, and with the help of it, predictive analytics can be done under data science. But predictive analytics is not only the single application of the data science. There are many applications are there. I'll show you few of them in our day-to-day life that we use, and then we'll talk about the detailed process of it. Now see, some of the real life examples that we came across multiple number of times. Top 10 applications I mentioned here. You can see this. I have searched something on the Google search engine here. How do I know if I'm an intelligent something? And I got some results, maybe more than 1 crore results within 0.46 seconds. Okay, they're extracted and they're shown over here. So is it really performing this operation with very fast, or is there any other algorithm present? It's a part of data science application design. Remember, it's very easily this algorithm can be used for you, but we are unknown to that. We just see the effectiveness of that algorithm, but basically how exactly it is done, that's the part of data science. Or if you see this one, targeted advertisements. Like for example, if you search something on Google, similar advertisement we can see on different web pages that you visit very regularly, or on Facebook also. Okay, you can get this, or on Amazon also you can see the Flipkart advertisement because they have reserved this space there. And it's what targeted advertisement is then. So most of the time these websites or these advertisements are connected with us. Okay, they're related with us most of the time. Okay, that also we can create, or we just see the recommendation systems. Yes, see this recommendation system. So in recommendation systems, whatever you watch, like for example, I watch a video on Netflix, so similar videos will be recommended to you. So the intention is that you will keep, or you will spend maximum time on that particular website, or the views of the respective movies, videos will get increased. On YouTube also similar things, or on Facebook also, people you may know, Twitter also, people you can follow based on some algorithm that they have created in data science. So based on that, the suggestions are given. I'll show you which algorithm is there, and if you want to create that, what type of applications or steps are involved. Yeah, recommendation systems. Or yeah, this is very common algorithm nowadays, which is used in the data science application, part of deep learning, basically image recognition. Let's take an example. When you upload a photo on Facebook, so Facebook automatically tags a particular person in that Facebook on that photo, sorry. Or even in Google Photos also, Google Photos also categorize your pictures as per the data present inside it. Like, so many such requirements are there that we can use here, and with the help of these requirements, it's possible to create image based projects. Most of the projects I have seen from last 2 years, they are coming under this category because of rise of Android application also. You just take a photo and perform the operation. Just like Google Lens is the best application of data science, but in image processing there. Okay, that we can do. So lot many image processing applications are there. For example, I want to find the disease of crop. So I'll take a picture of that crop and we find which disease is there. I want to find the cracks in the product. Take a photo, find a crack immediately without human intervention. Okay, so in manufacturing plants also, there are some cameras put at the manufacturing plant. So when the finished product travels through the line or to that particular chain, they take the photo and find that whether there's a crack, whether there's some flaws, some kind of problems are present on that particular product or not. So you can take these ideas also. But to understand, we have to use image recognition techniques. I'll show you which image recognition techniques are there, which we can use into the data science development. Yeah, one more, which is speech. Now we talked about image. It's possible to have a sound also, possible to have the audio also, by which we can recognize it, or we can convert that audio in the form of the text, or we can convert text in the form of the image, sorry, in the form of the sound also, in the form of audio also, like to and fro. It's possible. Google is already worked a lot on that. They have created such applications also, even not in English language, all the languages which are present across the globe. See, all languages, this kind of engines, speech engines are created. Even we can go more modified, more enhanced way to create these particular applications. Speech recognition, where data is there, but data is in the audio format present. Yeah. Even if you go to computer gaming, I have not played such games yet, but in computer gaming also, data science applications are done. Most of the games today, they are enhanced by artificial intelligence systems. So whatever we have played in the previous sessions, it may not be again repeated in the next session. Maybe next time we are having different scenario, and in that scenario you have to face Fine. So computer gaming can also be, games can also be created which are enhanced by data science. Okay, maybe if you have seen this person, yeah. So that's a Trivago's website. Trivago is a portal. They are not having their own hotel booking site. They just extract information from first portal, first website, second website, and then gives you comparison. Okay, just provide you facilitation by which you can choose the respective hotels from different kind of the websites. Okay, hotel booking websites there. Okay, as per your preferences, suggestions, you understanding them. They're also working on, they have created this data science application, and with the help of it, this particular website Trivago provides you the suggestions. Okay, or airline route planning, one of the most complex algorithm present here. It's very complex to check arrival and departure of different kind of airplanes on the okay, on in different kind of cities, airports. Or fraud detection, yes, I've shown that. In banking also we have seen this fraud detections. So if any person has made a fraud, okay, with the help of again data science algorithm, it is possible to do. Not only single in banking sectors, but almost in every sector, is the algorithm is working correctly? Is there any fraud present in this data, or by fraudulent information is used by some manipulation? That also we can find with the help of data science applications. And the last one is delivery logistics. Okay, if you order something from the e-commerce sites like Amazon or Flipkart, so they shows you the complete process. You started, you place order, then shipped, then it's traveling from source to destination, at where it's located, like everything, and they will predict that at this particular time, this particular date, the product will arrive at your end, like this. This is what data science application. So they are using the previous data, and with the help of that, these predictions are done. So here you can think of these kind of products also, not only talking about e-commerce website, but different kind of websites as we can use where recommendations are required, or we can do the predictions, predictive analytics with this kind of applications also possible. Fine. So they are the common applications. A lot many such scenarios are there that we can think of it, and based on that we can define a problem statement here. Okay. Yes. Now, before proceeding, we need to know what different kind of disciplines of data science is containing. So there are 4 prime disciplines are there based on the task that you have to do. We'll be dealing with 4 disciplines today. Machine learning, second is artificial intelligence. Actually, see, artificial intelligence is a main area. Under it, the machine learning is there. Under it, deep learning is present. Okay, artificial intelligence is a common name given to all the smart systems present in the computer algorithm. That's what we call artificial intelligence. And under artificial intelligence, we have machine learning and deep learning also, even natural language processing also. Okay, machine learning, deep learning, natural language processing. Now, what's the use of these technologies, these particular areas of data science that I will also show you one by one. We'll start with machine learning, then we'll go deep learning, then we'll talk about natural language processing. So when this kind of projects are done, then we require this, or this kind of pre-processing steps are there. How to handle and use that data, that also we will see. Yes, maybe if you are knowing it, or as madam has told already, you are having machine learning, but in next semester. But let's talk about that. But why I've given this, because in the previous slides also I talked about, we have seen the machine life cycle, data science life cycles, and in that I have shown one step number 6, which is that predictive modeling, and it's a brain. Okay, it's a brain of data science application development. Brain, you can see, if brain is not in your body, so what's outcome? So you'll be zombie. Nothing is possible. So brain, that's why machine learning is a brain. It's driving the complete data science application development process. That's why we call it as a brain. So whenever you design any kind of data science application, you need to understand the machine learning always. What is that, and which kind of data will be handled by what kind of technique, that also I'll show you. So what is machine learning? Machine learning is the simple as I told. It's an application of artificial intelligence that provides a system the ability to automatically learn and improve from experience without being explicitly programmed. So interesting that without programming, the algorithm will learn by itself. How do we learn? We learn from experience, previous experience. Same case, the machine will also learn, a computer system will also learn. Previous experience we have to provide. Based on that, the patterns inside the data can be followed, can be identified, and when the pattern is identified, we can use this pattern to do the predictive analytics on the given set of data. Okay, predictive analytics. So basically, when you have to do the predictive modeling or you have to perform the predictive analytics, in that case, we have to make use of machine learning systems over here. So this process of learning begins with observations or data such as example, direct experience, instruction, in order to look for pattern in the data and make better decisions in future based on the example that we provide. How do we learn? We learn from experience. Same method will be used by computer system algorithms also to learn by themselves. That's what machine learning is. So the aim is to allow computers to learn automatically without human intervention or assistance and adjust the actions accordingly. That's what the machine learning does. So it's a brain of data science application development. So you need to understand what machine learning techniques are and which technique will be applicable to this kind of data. Now you can see this. Just compare and check it. See, in traditional programming that we use data as input, program as input. So program will use that data and generate the output corresponding. Now, in machine learning, we are providing data and output as input to the computer program, and it generates a program. It creates the program there, means it designs the algorithm based on input and output. That's what the machine learning is. And once this design is done, then we can use this program to do the predictive analytics or to create the models which are based on the predictions, That's what we call as the machine learning. So this technique is applied. And how it is connected with data science? Now you can see this. Machine learning. So it's a development of computer algorithm for transforming data into intelligent actions. It's known as machine learning. We require previous data. See, when you have to design the data science project, first thing is that you need to understand machine learning. Remaining other operations are actually simple, but machine learning is somewhat lengthy process that we have to understand the steps, algorithms, processes which are involved in that. So we require data. So to use the machine learning, we require the previous data. As I told, with the help of previous data only we do the modeling. You create the models, and once the models are created, okay, after that only we can do the predictive analytics of it. Okay, available data. So on this available data, we use statistical method to build a model of it, and with the help of computing power, means software and hardware. Okay, specific softwares we require, like advanced software programming like Python and R will be required, and hardware like we need to use image processing, video, audio processing applications. So then we require the graphical processing unit, GPU, that is your the graphics card, or some high-end processor like maybe i5 is required, or maybe RAM of 8 GB, 16 GB is required. And with the help of it only we can build the machine learning application. So requirements are this: available data, statistical method we have to apply, and then we have to make use of the computing power ahead of it. Yeah. And again, under the machine learning, we are having three different kind of techniques present here, which is first is called a supervised learning, second is unsupervised learning, and third is reinforcement learning. So in case of supervised learning, okay, supervised learning, when you are designing a machine learning project or data science project, basically where the predictions are done, wherever the predictions are done, so that is we have to solve with the help of supervised learning algorithm. Okay, predictive analytics that we call, predict the next value, what will happen next with the previous data. Okay, second is unsupervised learning. In unsupervised learning, we just create the groups, clusters, similarity. Based on similarity, we create that groups are clustered within the data. Fine, that is what we call as unsupervised learning. And in the third case, it is reinforcement learning. For reinforcement learning, we learn from the mistakes, human tendency. We learn from mistake. We learn from others' mistake also. So similar strategy we can apply over here, and based on that we perform the operation. So as I told, machine learning is the brain of data science. Under again we have either predictive analytics, or we have some data-based analytics, data-driven analytics, like creating a groups, or we can have learning from mistakes, which is called as reinforcement learning technique. Okay, these are three different methods which will be making use of a brain for the data science application development. So that's what the main difference that we are having over here. Now, yes, now come with the actual point. The data diagram is very big, but I'll go snapshot by snaps, like 6 steps are there. These are the general ideas. In practical also, we have to focus on that. In data science application development, we have seen the life cycle, Now let's go with step-by-step application development, how exactly data science works. So in order to know the data science works, we have to know the basic concept of data science and basic concept of machine learning. And even at various stages of development, we may require the knowledge of deep learning, we may require knowledge of time series analysis, we may require the knowledge of natural language processing also. That also I'll show you why, when this knowledge is required, and what kind of projects are handled by these technologies here. See, 6 steps I have mentioned over here, which are required for common data science application development. First, we have to set the research goal. Second, retrieve the data. Third, data preparation. Fourth, data exploration. Fifth, data modeling. And sixth, data presentation and automation. We have seen the example. I've taken these case studies. Just keep any of the case studies in mind, and with the help of it, we can proceed further. All these steps, and under that, again, sub steps are there. Okay, so all the data science application design based on the previous data, and with the help of that data, we use that data, then we build a model of it, then we perform the operation. But remember, getting the data is number 2 step, building a model is number 5 step, and automation is number 6 steps. But along with that, 3 more steps I mentioned over here, which are acting as a building block for data science application design. See, in all, if I'm having a project of data science with me, out of it 20% work is required for building the model, data modeling here, 5. Remember, 20% work, and remaining 80% regard for remaining others. Okay, machine learning carries 20% part of data science, and 80% is the other work that we have to take in consideration for data science application design. Remember, so 6 steps are there which we require here in this particular process. Let's see one by one. The first process, setting the research goal. Basically, research is mentioned over here, but research and product, 2 things we require. See, for example, I want to do stock market prediction. Okay, whether you have to purchase the shares of this particular company or not. Okay, in future, what will happen, that we have to find. So we require a previous data for this. Previous data. In that data, the input and output, both values should be present. Input and output means this was the input, this was the output. That should be present inside it. Data should be always like that. Or I want to do some other kind of predictions. How much percentage a particular person will get, a particular student will get in the examination. I want to find it. So you require a previous data. Previously, similar student data, their previous outcome, previous marks also we require, and based on that we can build a model, and then we can proceed further. So we have to set what is your goal, what kind of prediction you have to do, what kind of prediction. I want to find whether I will get a heart stroke or not. Okay, like, so I require a previous data for health analysis, for that heart disease analysis. So these are the heart parameters, and these kind of persons were having heart attack, or these kind of persons are not having heart attack. Like, I require the previous data. Previous data is compulsory. So to set the research goal, or to set the goal of designing data science algorithms, we have to identify the previous data. In that data, whether your outcome variable is present or not, that should be identified. This is what exact data structure is there. Input was that, output was that. Okay, and based on that, we'll build the model, and then we'll do the predictive analytics. We'll use an automation-based data science project. Fine. So you have to identify that. What is your goal? What can be your possible input, and what can be your possible output? Like, if it is known, then only we require to create a data set, or we have to understand, or we have to use the previous data set which are available at different sites, or basically it's given by the clients. This is given from the research point of view. But whenever we develop the projects in companies, data is provided by the clients to us. Client provides this data. So this is my data, and I need to do this kind of predictions on this kind of data. So what will happen in future? I want to create this kind of predictive models. Okay, what will happen in future? That I want to identify. Like, it's given by the client basically, because they are giving the goal to us. Fine. This is what the first step to understand. You must be clear with every idea. What is your input? What is your output? Yes. If you don't know it, you are given some data set, and that input outputs are not present in the data set which is provided to you, it is of no use. It is of 0% usage. Remember that. That's the first thing that you have to be clear. Now, second, retrieving the data. Now, in companies, basically, as I told, clients are given the data set to us basically, and on that we basically work. So there is no any something like a client has provided the information that I want to create this kind of product and I don't have data set for that. It very rarely happens. They are giving a data, and based on that data we perform the design of the data science application development. But see, for learning point of view, basically, if you don't if you're not connected with the company and you have to learn or you have to design the product by your own, so we have to retrieve the data from multiple different sources. Multiple different sources, data sources are there. With the help of these data sources, we can find different kind of data, and we can use this data for performing or creating the data models or data science project development here. So see, there are two different kind of locations where we can get the data: internal data and external data. Internal data, which can be given by the client, or it's already available in your software that you use to design, already available, okay, or can be given by some other person also. They're also provided by them. Okay, so internal and external, two different locations are there from the data can be retrieved. Okay, so let's see, for our case, for example, if you want to design a particular project and no one has given to you, you require for your own ideas, you have to prove that you have to you are good data scientist, data analyst, or you can design the project so much easily. So there are many data sources from where the data can be taken. Okay, data sources from the data is available. So I have mentioned 6 of commonly used data sources where the data sets are available and can be used easily also. Okay, so see, the first one which I mentioned here is UCI machine learning repository. Second is Kaggle, this is data.gui.in or data.world or Condal or Analytics Vidya. Hundreds of such repositories are there. If I want to work on data science project and I don't have a data set with me, in that case, we have to search the data on special, trusted, or public repositories there. So these repositories are just like here. So they are used by many of the developers to design the project. The first, as I told or mentioned over here, is UCI machine learning repository. So just see this one. So which is very commonly used kind of repository from where we can get the data, and we can use this data for building the data science application development. You just check it out. I'll share this tab with you. Just a minute. Now you can see this. See, this is the UCI ML repository, which contains the URL. That's if you search in Google search engine for UCI ML repository, so you can easily get that. I posted that link in the chat box also, from where data sets can be taken. Okay, they are having trusted, donated data sets basically, and freely, openly available, means anyone can use for your internal project development also. Okay, you can see this, the front page I have shown over here. If you just go inside it, you can see view all data sets here. So once I clicked on that, you can see all different data sets are present. And what's the use of it, that also mentioned here. Total 588 data sets are present in this. See, all data sets are there. Okay, what type of data, default tasks, attributes, we can see they are mentioned in this. Different, whatever task you require, maybe that data set is available here, and very old data sets also present. That you can, you see, all are present, not only in text, but they are available in images also. Image data set is also present at this particular location of UCI ML repository. The second which I mentioned here, there was Kaggle. Okay, the Kaggle.com is the website which is under the control of Google basically. So you require a Google login here. You can see this Kaggle.com. Okay, from there also the data sets can be retrieved. And remember, Kaggle is the public repository. From where we can upload your projects, you can upload your data set also, and lots of code also you can find it. But they are just given as an example. It's not a project completely. For being a project, you have to do many different kind of operations there that we have to control. Now you can see Kaggle. From the Kaggle also different kind of data sources are present. You can just go to data sets here. See this at this link, data sets, and here many of such data sets are present. You can see the COVID-19 data set is also present. That also you can use. Fine. See, Arc Attack, UFA Champions League datasets, or many more, water quality and all. So, as per your requirement, you can download it. See, IMDb movie reviews also there. FIFA World Cup players, biological datasets you can see. From Kaggle that can be downloaded, that we can use it, use them from the Kaggle, and we can use this data for building a data science project. This is the second one that we can use. Even, just a minute. See, if we require the data related to Indian government, it's taken from Indian government, so you can use this site. You can see this. This is the data.gov.in. Okay. So the link which is shown over here is data.gov.in, that also we can use. So lakhs of 5 lakh almost data sets are present on this site. See, here it's mentioned 5,08,548 resources are present here. See, these are the data sets that we can download, and we can search it here. So if you want to work on a project where we require the data of India, means that data is required from the different kind of departments of central government or Indian government. So we can use this data set from here. Okay, that we require. For example, I want to do the predictive analytics, like what's the number of kilometers of roads, highways are built in last 10 years, if you want to see. So that data set is also available over here. If I want a literacy rate and I want to analyze the literacy of India, and based on that, you have to do predictive analytics. That also can be taken from here. Correct. So like lot many such data sets we can download from this particular link. Okay, they are available there, that we can retrieve the data from these locations. Or if you just go to another, see more site is there. This is the next one. See, okay, all of the logos I mentioned there. This is the data.world, from where also data sets can be downloaded. You can see this data.world. Here also you need to create a login. Even if you are working on a good data science project, you can sell your data also here. Selling of data is also possible. Okay, also you can do this here. See this. All this data catalog is present on data.world. Okay, next is Quandle, the fourth one. From where if you're working on finance or economics, so you can download data sets from this site also. This is the website of Quandle. You can see this. Link I posted in the chat box. This is the Quandle. What they are saying, world's most powerful data lives on Nasdaq's Quandle, but maximum financial data sets are present on this particular site. If you want to work, so you can have to create a login to this, and you can download data sets from this location also. Fine. And okay, many more such data sets are present. One more Indian website is there, which is Analytics Vidya. Actually, they are providing the tutorials, courses on that, but they are having data sets also present on their site. Here you can use it. Okay, it's a very great website actually that you can see. Okay, for data science. So many such websites we can use. Many such websites are possible to download data sets from, but data is important. So these are the common location from where the data can be taken, and then only it is possible to work on a data science project. So text data or image data. So Kaggle contains maximum image data also present on that. If you want to work on some image analysis, so we have to understand what kind of images are required, and you can download these images from the Kaggle's repository also. Fine. So these are the common locations from where the data can be downloaded, and we can use this data for your data science project there. This is what the main things to note. We data source, we have to download data, we have to use this data from the respective location. Make sure that the location that you're downloading is trusted, authentic. Trusted and authentic. Okay, so trusted and authentic locations only I have given. Many universities, foreign universities, European universities, American universities have created their own repository on their website from where the data can be downloaded. That also we can prefer. But these are the common repositories that we can use it. Now let's go with the third step. Data preparation. You can see different small steps I mentioned in it. Data preparation. So basically, before building a model, so we need to prepare the data. Okay, data, we have to prepare the data. But under data preparations, a lot many things. That is the largest process in all. Largest process, data preparation. Then second largest is data exploration. Fine. Then third is data modeling. If you go to the complexity of it, data preparation is very important, because you are getting a data and applying a model directly, and you will create the predictive model. It will not happen always. We have to prepare the data as per the requirement of the data science model, statistical model or machine learning model that we use. So see, under data preparation, 3 sub-steps are given: data cleaning, then data transformation, then data combination, data combining. Under data cleaning, again, if you have some errors in the data set, if it is physically impossible values are there, some missing values are there, okay, or outliers are there, spaces, typos are there, or errors against the code books are present. Now see, it's not an easy process. Process is easy but lengthy, that we can say. The data that we are downloaded, first of all, we have to clean the data, cleanse the data. So here 6 steps are mentioned. Errors from the data entry. Maybe the data entry is done by some person inside data set, and he has missed some data, or some wrong data is given there. And because of that, physically impossible values are possible. For example, I am having an age column, and in that age column, age of a person is given as 1000. So is it possible to have the age of 1000? Not possible. Physically impossible values. Or they're given the age -12. Physically impossible values are there. So that's what we have to remove. Cleaning, or missing values are there. Because of network error, because of database error, because of data entry operators negligence, missing values will be there. And it happens for multiple number of times. That also we have to take care. If this data should not be having any missing values present inside it. The next is outliers. We'll talk about outliers also. Outliers mean the values which are away from the crowd. See, basically, when you build the model, it is assumed that our data is clean. Clean means it is not having any indiscrepancies. For example, in a data set, I'm having a data with me, and there's 2 marks of different people are mentioned. Students are mentioned. And all the students are getting the marks from 40 to 70. All students got the marks from 40, minimum 40 to 70, and 2 students have got marks above 90. So these 2 students are called as outliers, because they don't follow the properties of crowd. Outliers. And if outliers are there in the data set, it may skew the result, it may change the result, it may not create the data science model correctly. So we need to take care of it. We have to delete the outliers, remove the outliers, and then only a cleaned data is possible. Or if you're having spaces or typos, space means unnecessary spaces are given in the data set. That unnecessary spaces should be removed, should be deleted. That's what we call a stripping of the data. Starting and ending spaces are removed, and the clean data should be available with us. So most of the time, when you work on natural language processing, like for example, I want to create a data science project where I'm talking and I just want to convert that speech into text format. So that spaces are not required. Spaces will be used to separate the words, but they are not actually useful in the analytical process. So we have to remove that particular spaces, and after that we have to use the particular data for analytical operation. This is what unnecessary data which is present in the data set that should be cleaned with the help of the data cleansing. So if you talk about the things practically, how can you clean the data? There are many different steps are involved that we can use. We generally call it as imputing a data. Imputers are the classes, objects which are used to clean the data, that we have to take care of it. If data is not cleaned, model creation is not possible. Model will show the error directly, because data models are created with the help of statistical method. A statistical method will work only on the numerical values. Missing data is not a numerical value. That's why they will not create the model correctly. That's why data cleaning is expected. Now, second step which is mentioned in data preparation is data transformation. Remember, data transformation. Not always data is taken as it is. Data is taken and I have used that data. It will not happen for data science projects. So practically, when you use this particular data, we have to transform the data into the required format. I'll show you. I'm having a separate slide for that. What exactly data transformation methods are there? And next is combining the data. See, combining the data can be one of the main process of data transformation, because data can come from multiple sources. For example, I want to do the weather analytics, weather prediction. So, but I'm having the data for weather prediction year by year. 2010, 2011, 12, 13, 14. What will happen in future? We'll see current situation from last 2 to 3 years. We have seen different accident, different kind of incidents of high floods, okay, or landslides. Maybe in upcoming future this will increase, but I want to do the prediction. What are the reasons? What may happen? So you can use the previous data for that. For example, the data is available year by year for 2011, 12, 13, 14, 15, 16. So to use that data, I need to combine all, because model will be created on the combined data. So you have to merge, join, combine, concatenate this data. And after that, only data is possible. So all these things will come under data preparation. So directly the data is not given to this. Okay, now see, different techniques I mentioned over here. Data science is, though it's a systematic process, but depending upon the type of data, we have to use different preparation methods. So what kind of data will be available? Now see, maybe those who are already working on data science project, maybe they are knowing this particular terminologies which are mentioned on the data preparation over here. See, different tasks, different models that we can work on the particular data I mentioned here. Maybe you can do a classification, maybe you can do regression, maybe you can do clustering, maybe we are having a non-structured plain text, maybe we have videos data, we have time series data, we have transaction data, we have images data. See, different kind of tasks are there, different kind of data is present here. Based on that, we have to do different kind of operation. Now, what's the meaning of all of this? See, classification in the data science, if you want to do the prediction in the class format, like for example, I'm capturing an image and I want to find whether that particular image belongs to dog or cat. Two possibilities are there, correct? Or I have taken some input from the cancer patient. So you can identify whether that person will have cancer or will not have the cancer. Two possibilities are there. I want to do the predictions of it. Okay. Or I have taken some input from some of the health data sets, and I want to check that whether what kind of disease the particular person is having. This is A, this is B, this is 3, or this is 4. Like, so what your expected outcome is, it is class, it's a category. So that time we'll be applying classification algorithm. Now, if you are not having class as the outcome, I'm having continuous value. I want to do the stock market prediction data set. Okay, or I want to identify the mileage of a car, manufactured cars, mileage I want to predict, stock market, or I want to predict the price of dollar, okay, in upcoming future, or I want to find how much amount of area covered by the forest in future and what will happen in future. So this is what we are having continuous values. That time we have to apply the regression kind of algorithm, this one. Okay, that time we need to apply the regression kind of algorithm. This regression kind of algorithms are required for the such cases. If outcome is continuous, that algorithm will be different. Maybe if you're having, okay, for this classification regression, we should have input output both. For if you're having only input, then we have to apply the clustering techniques. Only input, and inside that we are going to find the groups. First group, second group, they are similar, these are similar, these are similar. Like similarity notions are used, and based on that grouping is created. When only input is there, then it's a task of clustering. Okay, now for these three cases, the data is in structured format. Data is in structured format. Okay, the example which I told, if you want to work on such kind of data where input output is there, then we have classification regression. Okay, and if only input is there, we'll be having clustering techniques there. So three techniques are present in common machine learning algorithms are having, and they are working on structured data. Data is in table format, rows and column format. Now, if the data is not in the row and column format, it may be a time series data which is stored according to time. The data which is stored according to time, just like for example rainfall or sale of a particular company from last 5 years I mentioned. rainfall in a particular region from last 6 years. Sure. So this data is stored according to time, and we have to create a data science model. What will happen in future? So what measures you have to take according to time? So that time you have to make use of time series methods. Time series is a complete different method which is not present in this category. It's a time series. Data is stored in the form of time. Maybe we have data in the form of transactions. Transaction, unstructured data. First row contains some 7 transactions, second contains 2 transactions, 10 transactions, 12 transactions, 5 transactions, 1 transaction, 11 transactions. Like unstructured data is there. That's for the transaction data. Maybe we have plain text data. Whatever we are talking in that format, data is given. All tweets of the Twitter are given. Tweets from the Twitter are given. All the posts which are done in text format on Facebook are given there. The data from the Wikipedia is extracted. Data from a book is extracted. Complete non-structured data is there. This is non-structured plain text. That may be again possible. Or we are having input data in video format, video or image format there. So based on different kind of data set, different kind of data are possible, and with the help of this particular data, we have to decide what kind of model, machine learning model we have to apply onto it. Maybe clustering, classification, regression, time series, they are the names of model itself. The meaning others are the not model, they are the type of data basically. And on this particular type of data, what kind of data science model we have to apply, that also I'll show you. So these are the different ways data may be available with. Now, to prepare the data, as I told, maximum is the largest step present inside the data science application development. Those who do this operation perfectly, their data science project is the robust and one of the best project can be created when you are designing or when you are preparing your data so well. See the list of techniques which I mentioned over here for data science. Fine. Data cleaning, I mentioned already that. Data cleaning, when you have missing values, when you have impossible values, when you have some erroneous values in the data set, that time you have to clean the data. The clean, this is the first step which is involved in the data science application design. Second, correlation techniques. Now see, as I told already, whenever we are using the data machine learning techniques, so we have to apply input and output. But remember, we have to identify that whether input is connected with the output or not. Whether input is connected with output. Sorry, output is connected with input or not. So to check that correlation, collinearity basically, correlation or collinearity, will be making use of some correlation technique. With the help of correlation technique, it is identified that the output variable is dependent on input. Dependency, linearity, yeah? I'm talking about linearity, linear dependency will be there. Linearity will be found. So there are 3 correlation techniques present: Pearson correlation, Spearman correlation, and Candles correlations. Out of which Pearson correlation, if you heard about in mathematics or not, I don't know. So that techniques are used. With the help of it, the linearity is identified. Input and output data are linearly connected or not, but that will be used only for linear models, not the other ones. Then the third technique that we embed here in the preparing a data is called as outlier detections. I told about outlier also. Some features, some data which does not follow the properties of crowd. If that data is present in the data set, it may not create the robust or clean or useful data models. Okay, so we have to detect that outliers, we have to remove the outliers from that. Detect the outliers or remove the outliers. That's what the requirements are, and these requirements are satisfied with the help of outlier detection techniques. So technically speaking, there are 2 different methods by which the outliers can be detected. Okay, the first method is called as the general, means univariate method, and second method is multivariate method. Univariate method means on single feature only you have to delete the outliers, and multivariate means in combination of all we have to delete the outliers. So there are some machine learning techniques also present that we can use, and we have to delete the outliers. Outlier deletion is also one of the way of data cleaning. The data which does not follow the properties of crowd, that you have to delete from it. Then fourth step is normalization. Normalization. Now normalization is again one of the most important pre-processing step in the data science application that we generally do. Don't apply the data directly. See, some of the machine learning models are very sensitive for magnitude. They are very sensitive to magnitude. Magnitude changes, result changes drastically. When magnitude changes, the result will lead to change the drastic changes in the final result also. That may be the problem present there. So what we require, we have to normalize the data in that case. Normalize it. Keep data in the same range or keep data with the similar deviations. Okay, keep data with a similar deviation that we have to do. And after that, data is normalized, then only the behavior of machine learning model will be perfect in these cases. Okay, that's one of the phase, one of the stage which is required for preparing data, normalizations. So under that, multiple three basic techniques are present. Out of it, first technique we called as feature scaling, second technique we called as min-max normalization, third technique is called as robust scaling. So any one of that technique will be used by which the data can be normalized. So most of the algorithms are very sensitive to the magnitude of the data. So you have to release or decrease that sensitivity. If you want to decrease sensitivity, you have to normalize the data. Then the fifth step is encoding. That also required, but not required always. Depending upon the type of application, you have to use it. Encoding. See, data science application development is a statistical process. Statistical models are created there. So make sure statistical models are based on numbers, mathematics, maths, numbers. Okay. Now see, if I'm having a data into the string format, then the model cannot be created. Data science models cannot be created clearly. If data is string format, like in a column, I'm having male and female, MF or MALE or FEMALE, something like as written there. And I want to apply that data as input to the data science algorithm. It will show the error that string data cannot be used by any statistical model or machine learning model. So you have to convert that data into number format. String data in number format. Maybe for female 0 number is given and for male 1 number is given. 0 and 1, or if more than two categories are there, will have 0, 1, 2, 3, 4. Some numbers can be assigned to it. This technique is called as encoding that we generally apply. When the data is when applied, when you're having data in the string format, that time we applied. So encoding, it's of label encoding and one hot encoding. These two methods are label encoding and one hot encoding. These two techniques are present, or any one of that can be used to perform operation of encoding the data from string format to the numerical format that we use. Remember, so it's depend if you're having string data or not. And the last technique to prepare the data is called a data resampling. Basically, data resampling technique is applied only to the data which are having class as the output, category as the output. It means that whenever you build the model, you should apply the data with equal instances. For example, I want to build an image recognition model, data science model, by which you can identify that whether the particular image belongs to, it's an apple or is an orange. If it is an apple or an orange, I just want to find what kind of fruit is that. I want to design an algorithm. So I want to give input to the algorithm first. So equal entries of apple and orange should be given. Out of 100 entries, 50 entries of apple, 50 entries of orange. But if it is not the case, if you have 95 entries of apple and only 5 entries of orange, so machine learning model cannot be created correctly. Robust model is not possible. So this data we call as the imbalanced data. This data we generally call as the imbalanced data set. So you have to balance it first. Keep both entries same. Both entries same. Okay, maybe 50-50 are present. And then only a perfect data science machine learning model will be created when the data is balanced format. That time only. So we have to make use of data resampling, but that's not always required. If data is not balanced, data is imbalanced, that time only we will be making use of the data resampling technique. So there are three techniques present there. Okay, that's not mentioned here. Random oversampler, random undersampler, and SMOT. These three techniques are used basically to resample the data set, means to balance the data set. And even in machine learning also, there are two more techniques present by which the data balancing is possible. See, that's what the preparation is. Means making a model can be easy task, but preparing a data for the data science application project development is very essential, vital, important task, and that should be taken so much carefully. So depending upon the type of data, we have to make use of this technique to prepare the data for you. Fine. Okay, this is what data preparation is. Let's go with the fourth one. Fourth step which is present here in data science development is exploratory data analysis. Again, under that multiple steps are the data exploration. We have prepared the data, we have converted data into specific format, but after that we are going to decide what kind of algorithm we have to apply on that data. What kind of algorithm we have to apply, what kind of discrepancies are there, whether data is normally distributed or not, okay, whether how much up and downs are there present in the data set, or which features are important for building the model and which are not. These kind of decisions are taken here in the data exploration. The data exploration can be done by two methods. First is statistical method and second is the graphical method, means visualization method. Let's see that. Okay, graphical method or visualization method. Now first, visualization. Now see, one thing is to note that we are building the machine learning models or data science models basically. But before actually building a model, you should know the complete picture of data. What kind of ups and downs are there? What's the minimum maximum value present? Whether data is normal distributed or not? Whether the data is having some impossible value. Already we have cleaned that, but we can just take an overview of complete data in a single picture. And because of that, we have to make it the data visualization methods over here. Data visualization is a presentation of data in a pictorial or graphical format. Data is in picture format or graphical format that we can use. Graphs can be given, like for example, if you use a line chart, so we can identify data is linearly connected or not. Line chart. Scatter plot, we can see data is having groups similarity present inside it or not, cluster present inside or not. By using scatter plot we can see. By using pie chart we can see what kind of data is having highest shares, what kind of data is having lowest shares inside it. Or if you use a box plot, we can identify the ranges of data, median of data, or you can identify outliers of data also. Fine. So based on different kind of graphs, we can grasp the difficult concepts inside it and identify the new patterns present in it. You can grasp the difficult concept and identify the pattern present in that. That's why to explore the data, to do the exploratory data analysis, we have to make use of visualization methods here. So with interactive visualization, you can take the concept a step further by using technology to drill down the charts and graphs for more details, interactively changing and what you see and how to process, how it should be processed. Okay, what model should be chosen, that also we can identify with the help of data visualization methods over here. So with so much information being collected through data analysis in the business world today, we must have a way to paint a picture of the data so we can interpret it. Best way of data interpretation is not statistics, it's visualization. Statistics also okay. Those who understand statistics easily, they can make use of statistical methods by which the interpretation of data can be done. What kind of operation we can do on the data can be finalized. But if you're not comfortable with statistics, use graphical methods. Okay, so the data visualization gives us a clear idea of what information means by giving it a visual context through maps and graphs. And important thing is to note that this makes data more natural for human mind to comprehend, and therefore it makes it easier to identify trends, patterns, and outliers in the large data sets. I'm having lakhs of entries. What's the trend it is having? There the data is linearly connected or not, that we can find with this. Or whether the data is having specific groups within it or not, that we can find with the help of data visualization. Or if still the data is having some outliers present inside it or not. So outlier detection and removal, detection basically, can also be done with the help of data visualization methods. So visualization is very vital part of exploratory data analysis. Exploration of the data can be done with the help of visualization. So try to understand the meaning of it. There are several techniques. If you use programming languages like Python and R, inside it lot many libraries are there, pre-built inbuilt libraries are present. With the help of it, visualization is possible. But specifically if you want to work only on visualization, there are some technique like Power BI or Tableau are present. They are the commercial tools basically, which also we can use to visualize the data and get the clear and clearer picture of it, so we can decide which kind of model we can apply onto the data, and based on that the machine learning project or data science project can be created easily. That's what the visualization. Now, yes, now Data is prepared, we have seen the data, and now we have to decide which features. So basically we have a structured data present. For example, I want to do the diabetes prediction of my body, but I require a previous data of person who were having diabetes, who were not having diabetes, and different columns like weight of the person, different glucose concentration level of person, or BMI, or many different parameters are there. And based on that, it is decided, it was stored inside data set, that whether the person was having diabetes or not. Correct. So if I'm having 10 inputs and one output, 10 inputs are there and one output is present, but out of 10, which features are important and which are not, which features are important and which features are not important, that we have to identify, because I don't know which feature are important. So we have to apply some statistical method by which important features can be extracted, important columns can be extracted, and only that column will be used to build your machine learning model. Only that columns will be used to build the machine learning model. And to do this one, we use methods called as feature selection. Feature selection. Select the features which are most beneficial or most we are having highest impact in the output generation. That's what feature selection is called as. There are two different techniques which are present in feature selection. First is called as filter method. Second are called as wrapper methods. Okay, it depends. Filter method basically works only on input, and wrapper method works on input output both. You check the combinations of both. And there is one more technique called as it's in wrapper method itself, called as recursive feature elimination, RFE. And there is one more technique called as forward feature elimination, FFE, and one more technique called as backward feature elimination, BFE. These techniques are used for feature selection. Which features are important, which are not. See, if you are building the machine learning model with 10 features, okay, it will give some good accuracy, and with 2 features also will have similar accuracy. Then why to waste the time in using that remaining 8 features? Because with 2 features only we are giving high accuracy. Then why 8 features are required? It will waste the time. So we have to minimize the time for building the machine learning model in the data science application development. So to do this one, we have to eliminate the features columns which are not important. That is done with the help of feature selection method. Okay, and the second method, this is the first method, or second can also be used. Second method we call as feature extraction. Feature extraction. So feature extraction has given another name. It's called as dimensionality reduction. Dimensionality reduction. Dimension means number of features. Dimensions, like. So feature selection, we select exact feature, but in dimension reduction, the data will be converted from one format to another format. It may delete the redundant features, okay, or it may combine the similar features, okay, or it may convert feature from one format to another format. Maybe anything is possible. That's what we call as dimensionality reduction. Outcome is same, okay, but different statistical method. I think if you have heard about eigenvector, eigenvalues, these techniques are used for dimensionality reduction. With the help of it, the number of dimension, number of features which are required to build the data science model will be decreased. Unnecessary feature will be removed. So for dimensional reduction, again, there are 3 techniques present in common. First technique we call as principal component analysis, PCA. Second technique we call as linear discriminant analysis, LDA. And third technique we call as factor analysis, that is FA. With the help of any one of this technique, feature selection is possible. So out of all, either feature selection we can do or dimensional reduction. And under feature selection also one technique you have to apply, or in dimensional reduction also one technique you have to apply. So this is what we call a feature engineering. Using or selecting appropriate feature decides the robust data science project created. Fine, that's what important thing is to note there. Okay, feature engineering, one of the best way of data exploration. Yes. Now, before building the model, the most important step also we do, that's called as cross validation technique. Cross validation is validate the model. We create a data science prediction based model, but how do we know that the model is perfectly created? Is it possible to create the model perfectly? We can create a perfect model, but how to validate it? How do we validate this particular data? So to perform the operation, there are many cross validation techniques present. Out of it, one of the commonly used cross validation technique is this, which I shown here. Maybe if you heard about it, See, you have a data set previously present with us. So what we do, we split the data into two formats, training and testing. Okay, with the help of training data, we build the machine learning model, training data, and testing data is to test that the model is created correctly or not. It's called a holdout method. Means we are keeping this data on hold separately, on hold. Data is taken, and when the model is created, then we use this data, testing data, to test whether the model is perfectly working or not. Unseen entries are given to the model, and we'll check that whether it's perfectly working or not. So this technique we called as a cross validation, which is compulsory. Why it's compulsory? Because of this data, we can easily identify that the machine learning model, data model that we have created is perfectly working or not. So the technique which is shown over here is called as holdout method, which is it's also called as a train test split method. We convert data in this format, and then after that model is created, we use the test data to check whether the model is perfectly working or not. Along with that, there are many more techniques like called as k-fold cross validation. Another method is called as stratified k-fold cross validation. Another method is called as LOOCV, leave one out cross validation, grid search cross validation, random search cross validation. Different techniques are present there, and with the help of it, we can perform the cross validation. And when the model is created, we can validate that whether the machine learning model created is perfect or not. Yeah. Okay, these are the common techniques we need to know. Now, before proceeding the model, there is one more terminology that we have to take care. That is called as semi-supervised learning. It's not always required. Very rarely it's possible. Now, see, we have seen the data with missing values. If data input data is having missing values, correct? Input data is having missing values. Then we perform cleaning operation. But see, if output data is having missing values, then what to do? Output data is having missing values, then what to do? So in that case, there's a special method in data science we apply. It's called as semi-supervised learning. Semi-supervised learning. See, in supervised learning, we are having input output both, and there's some model is created. In unsupervised learning, we have unlabeled, output is not there, only input is present. Then we create the model. But if you have some labeled data and lots of unlabeled data, means input output are present both here, and here only inputs are present, output are not present, then what to do? In that case, there is a technique which is mentioned over here, semi-supervised learning method is applied. Okay, we build the model. So make sure if your output is having, rarely it applies, output is missing, that case. And there are two techniques which we generally use in semi-supervised learning. The first technique is called as label propagation. Okay, label propagation, the first technique, and second is label segmentation. So these two methods are present. With the help of it, it's possible to build the machine learning model. But when we're having output data missing, in that case only the semi-supervised learning methods are used. And let's give the again brain of the data science application development here, which is model building, the fifth step, which we carry out in data science application development, building the model. Okay, so step number 5, you can see this one, data modeling. Okay, and what it contains: model and variable selection, model execution, model diagnostic or model comparison, which is done into the data models. Now here comes the application of machine learning system, which uses this data. After getting all the prepared data, we will choose a robust machine learning model. With the help of it, the predictive analytics is possible. Now see, there are commonly two different kind of models present. With the help of it, we can do the predictive analytics, linear and non-linear models. When your data is having linearity present inside it, then we'll be using the linear models. And when your data is not having any linearity present inside it, we'll be using non-linearity model. Now, how to check linearity? Correlation method I told about it. Okay, if linearity is present, use linear models. If it is not present, use non-linear model. That simple is this. Fine. So see the machine learning models I have mentioned over here: linear regression, multilinear, polynomial, logistic, lasso, ridge, elastic net, isotonic, robust. These are the common regression methods. Linear method basically are present here. Okay, which we can apply to build the model. So for linear regression, with data 1:1, they are connected, one input, one output. That time we will be using linear regression. But when you have multiple input and one output, we'll be using multilinear regression. Correct. Line, they are the input and output are connected with the line. That time we'll be using this particular methods. But if input and output are connected with a curve is there. That time we'll be using polynomial regression, the next one. Okay. Now next is logistic regression is a classification algorithm, means we are generating a class as the outcome. Output is a class, category is there. That time we'll be making use of logistic regression, but linearity is there, output is a class. That time logistic regression algorithm is used. Next is lasso regression. Lasso, ridge and elastic net. They are of similar category, only the statistical differences that they are having. Lasso regression uses L1 normalization, L1 L1 regularization. Ridge uses L2 regularization, and elastic net uses L1 L2, both regularization methods in this particular system. Isotonic regression, many techniques we can learn by your own. So as per your ideas, we can choose this particular model, or if you're having non-linear data, non-linearity is present, that time we'll be making use of these techniques. Decision tree classification regression, random forest classification regression, support vector machine classification regression, k nearest neighbor classification regression, and new base classification. So these are the common methods which are present in non-linear modeling. So when you're having the classification data to generate the class, we can use this technique, or output variable in continuous format, not in the class format, that we'll be using regression methods here. Okay, so the different kind of algorithm that we apply. It depends. If you know the machine learning, you have to learn machine learning, then how the algorithm works. Based on that, you define specific algorithm to work on that, and then we can evaluate it. Now see, other form of models, we can have linear, non-linear, but some machine learning models, data science models, are based on different techniques here. See, we can have probability based models. Some machine learning models are based on probabilities. Logistic regression is a probability based model. What is the probability of output? You might be knowing probabilities are like possibilities. Or Bayesian models, new Bayes model is based on the probability. What is the probability that the output is this? What is the probability that the output is that? Like, they are based on the probabilities. Or there is one more technique that we can apply here in data modeling, is called as kernel based models. Kernel based support vector machine is a kernel based models. So under that we have linear kernel, RBF kernel, sigmoid kernel, or we are having polynomial kernel. So different kind of kernels are there, that kernels can be applied, and with the help of it, more accurate machine learning models can be created. We can use support vector machine, but the disadvantage of support vector machine is that its speed is very less. Complex models are created by using SVM. That's why it's not preferred. Accuracy is good, but the speed of working is less. That's why. Or we can have lazy learning models like k nearest neighbors. K nearest neighbors. Accuracy of such kind of algorithm, k nearest neighbor, is at high level always. This is my observation also. When you have to build a data science project, we'll be preferring KNN algorithm for most of the time because the accuracy is high. But the problem is that they are having less time in the predictions. The model will be created easily, but for prediction it takes time. For prediction it takes time to the prediction. Accuracy is good, but that model can be also created. You have to learn that machine learning models there, how lazy learner works. Or there is a novel technique nowadays available in machine learning. It's called as ensemble learning. It's called as ensemble learning. So these ensemble learning techniques can also be applied. Now remember, in the data set, I have not mentioned in prior slides there. In the data set, there are two different kind of errors may be possible, and that errors are called as bias error, or variance error. Bias error or variance errors. These bias errors and variance errors can be automatically removed with the help of ensemble methods, which are mentioned over here. Ensemble, these are the machine learning technique basically, which you can see here. Bagging, boosting, stacking. Okay, bagging, boosting, stacking, and voting. These four methods are there which are used in ensemble. Ensemble means combining multiple machine learning algorithms together and then build the model. It's called as ensembling. So bagging is used to remove the bias from the data set and build an accurate model. Boosting is used to remove the variance from the data set and to build an accurate machine learning model. Okay, so depends whether you can use bagging or you can use boosting. Or third case, stacking. Stacking is used to create the most accurate classifier. It is one of the way by which can combine multiple algorithms together, stacking and voting. See, it's very interesting to see this technique where we combine multiple kind of algorithm together and we build the robust data science model there. This technique can also be applied. Okay, so depend what kind of application we have. Based on that, you choose the respective model. I can use probabilistic model, kernel based model, lazy learners, or we can use ensemble learning also. Ensemble learning is actually most effective in my experience. In all of them, stacking can be the most accurate classifier in most of the problems. Stacking, where you combine multiple algorithms, two-stage development is there that stacking contains, and with the help of it, one of the great best machine learning model can be created there. That is what the ensemble learning is, and these are the many different kind of machine learning model we can use to build your systems. Many novel algorithms also coming, like for example, artificial neural network, which I have not mentioned over here. Artificial neural network, that also we can use ANN, and but complexity of ANN is very high, and accuracy is also good that we can use to build this particular model of machine learning with the help of artificial neural networks also. So this is what the world of machine learning is, and which is the brain of the machine data science application development that we have to use. Basically, what exactly we do, we perform operation based on trial and error. See, what is your preference? Two things that we generally use, okay, for building a data science project, whether you require speed or accuracy. See, in case of if you see about the ensembling technique or artificial neural network or SVM, they are not having good speed for building the model. They are not having good speed in the building model, but their accuracy is good. And if you see decision tree kind of algorithms, then their speed is great, but accuracy is moderate. So whenever we require speed, we can use decision tree algorithm, we can use new based algorithm, we can use logistic regression algorithms. Speed is desired. But when the accuracy is desired, means preference is accuracy, that time we can use ensemble methods, k nearest neighbor methods, or we can use support vector machine methods, like what. So it depends what kind of exact preference that you're having, accuracy or speed. Based on that, you define what kind of model we have to use. So such hundreds of machine learning models are there, out of which are very regularly available, very effective, efficient. Only that names I mentioned on this particular slides, and based on that, the brain of data science project can be created. Fine. Yeah. Now this is what classification regression algorithms are. Now, what about the data? For example, you have to you're working on a data set which is having a time present inside it. Data is changing according to time. I want to predict the sale of my company. Okay, sale in future. Just like I just have told I want to predict the rainfall in a particular year. So I'm having a previous data with this, and this data is stored in the form of the time. Time is not only time, it can contain weekly data, daily data, monthly data, yearly data, like that is time series data itself. The data which is stored according to the time that we are having here. Okay, so a time series is a series of data points indexed in the time order. Okay, so that case, it is not coming under this machine learning technique. So we have to use a time series analysis separately. The most common time series sequence of taken a successive or equally spaced point in the time. So it's a sequence of discrete time data. Example of it, like heights of ocean tides, they are changing according to time. Count of sunspots and daily closing value of stock market, changing according to time. So when you have to work on such kind of data, we have to use a time series. So time series analysis comprises of methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. Fine. Time series forecasting is one of the use of model to predict future values based on previously observed values. You can see increasing for last 5 years like that, and if you follow this trend, what will happen in future? That prediction we can do with the help of time series analysis, which is not the it's a data mining algorithm basically. Time series. Then to do the predictions, data mining algorithm of time series analysis will be. There are many techniques present in Python and R also. With the help of it, the analysis of time series data is possible. So when data is in time series, we cannot apply the previous techniques there. Now, another method. There is one more way by which the data analysis project can be created. So, and it is called as association rules. The data, when you're preparing the data, I have given one name of the data, it's called as transactions. When we have a data in transaction format, like for example, I just have shown recommendation systems there. I want to build a recommendation system for any particular company. Like if someone has watched this video, I'm suggesting that videos also. If on Amazon the particular person has purchased this, so we can suggest that also. Okay, suggestions can be given there. So by that we can improve the sale, we can improve the time, spending time, client spending time on your website with the help of these particular ideas. And this we called as the association rules. So there are many ways to see similarities between the items. These are the techniques that fall under the general umbrella of association. General umbrella of association. And the outcome of this type of technique in simple term is a set of rules that can be understood as if this then that. Set of rules that can be understood as if this then that. So this is what we require. If the data is like that, this is called as association rules, and that can be treated differently. You can see this one. If I'm having such unstructured data completely, so machine learning basically go on unstructured data. If like that, then you have to make use of some different technique of association rule mining. You can see particular customer has purchased this item, this item, this item, these items, like 3 items, 4, 3, 2, like or. And in that I have to find the rule. If customer is purchasing milk, he's most likely purchasing bread also. Connectivity, correct? So this is a recommendation system. He's purchased milk, so he can suggest bread. Suggest a new suggestion can be given. So association rule is one of the technique which is we apply. So based on the transactional data, if it is transaction format, that time the algorithm of association rule can be applied as the model. So there are 3 different techniques which are present in association rules. The first technique is called as a priori algorithm. Second technique is called as FP growth algorithm, that is frequent pattern growth. And third is called as the ECLAT algorithm, equivalence class transaction. That algorithm is there which is used. So this technique can be applied for building the association rules models. Okay, now another technique. Now if the data is not in unstructured format, sorry, not in structured format, data is present in unstructured format. So it's a big question. So to solve that particular problem, we'll be making use of the natural language processing technique, NLP in short. What is NLP? NLP, it's a branch of computer science, and more specifically branch of artificial intelligence, concerned with giving computers the ability to understand text and spoken words in much way the human being can do. That's it. And it combines the computational linguistics, rule-based modeling languages with statistical machine learning and deep learning model, natural language processing. See, for example, I want to do analysis of reviews which are posted on a particular application, posted on a particular website. Okay, or I want to do analysis of sentiments. For example, recently, just like a day before, India has got first silver medal in the Tokyo Olympics. So I want to see the analytics, what people are talking about the player. So I can use that hashtags and I can extract information and I can analyze this data. But in that data, we have to apply natural language processing applications. This is an application of NLP. Okay, natural language processing that we have to use. So basically for natural language processing, there are many techniques are present that we have to do. We have to understand most of this is my observation from last, again, 4 to 5 years, maximum people are moving towards NLP, natural language processing. We have to do this kind of idea, that kind of idea, another kind of idea. And NLP can be done on all kind of languages, not only talking about English, but if you're having language other than English, that can also be analyzed with the help of NLP. So if the data is unstructured, then we have to convert that data from unstructured format to the structured format. But before applying natural language processing, we have to apply natural language processing before it. Okay, now you can see this special pre-processing technique we require. If you are having a data in association rule format, so association rule data is also unstructured. We have seen that baskets, they are unstructured. So that data will be converted into structured format by transaction encoders. Okay, and if you're having a data in plain text format, like for natural language processing data is there, then we have to use TF-IDF vectorizer. Okay, term frequency and inverse document frequency. That is what TF-IDF is. Term frequency, inverse document frequency vectorizer. With the help of it, unstructured data can be converted to structured format. We see all data science models, all they work only on structured data. Remember, if the data is in unstructured format, there are some techniques present in data science by which you have to convert this unstructured data into structured format. Unstructured data into the structured format. So association will contain unstructured data by the transaction encoding converted to structured format. NLP also contain unstructured data by using TF-IDF vectorizer converted to unstructured format. If you go ahead in image analytics also, data in unstructured format, you have to convert the data into structured format, and then only we can make use of this specific technique to work on this. This is what special pre-processing technique required there. So data in unstructured format, we use NLP, natural language processing. Is a very big field. A special study area of study is that NLP is, remember. Okay, now yes, so another kind of model that we require, we may require the data models of deep learning. If you heard about deep learning, machine learning is common method by which you previous data to perform predictions, but same deep learning is there. But the difference is that deep learning makes use of deep neural networks to find a solution to it. So deep learning is also artificial intelligence that imitate the working of human brain in processing data and creating pattern for use in decision making. That's what deep learning is. So deep learning is a subset of machine learning in AI that has network capable of learning supervised, unsupervised from data that is unstructured or unlabeled. It's also known as deep neural learning or deep neural network. So whatever human brain is having, human brain can be converted into neural network format in computer algorithmic format, and with the help of it, the predictions are possible. That is what deep learning is. And especially if your data is in image format or if your data is in unstructured format, we'll be making use of deep learning techniques. Let's see how to do this one. See, for example, CNN. The first case, convolutional neural network, CONV-NET, CNN. So there are two different algorithms present in deep learning, common algorithm that we use in deep learning. The first is convolutional neural network, CNN. It's a deep learning algorithm which can take in as input image, assign importance, that is learnable weights and biases to various aspects in the image and able to differentiate one from other. So if you want to do image classification, we have to make use of the deep learning algorithm. That is convolutional neural network algorithms, CNN in short we call it. Okay, image data. Because CNN is very big concept basically that we can learn and we can solve the image analytics with the help of CNN. And second is RNN, that is recurrent neural network, RNN in short. It's a type of artificial neural network which uses sequential data or time series data. Sequential data is having a sequence. For example, if you observe, when I'm typing something in Gmail, for example, if you write dear sir and then please find the automatically attachment name comes up here. It's give the suggestions to you. Data unstructured, but you are giving a suggestion because previously that pattern was there that present inside the emails of Gmail. With the help of that, they have done the prediction, and this is a sequence present, and that sequential data can be used with the help of recurrent neural network, RNN. So these deep learning algorithms are commonly used for ordinal or temporal problems such as language translation, natural language processing, speech recognition, and image captioning. When your data science project is coming under these categories, you need to use a recurrent neural network algorithm in such cases. Fine. So it's not like that. If this data is there, any algorithm can apply. Depending upon kind of data, kind of objective that we have, you have to decide your algorithm. So as I told, if this situation is there, then that kind of algorithm is required. So we need to understand what pre-processing techniques are involved there, and with the help of this pre-processing technique, we can make your data useful from the point of machine learning or deep learning algorithm there, and then a robust and perfect model can be created there. This is what the step number 5 for model building. What different models are there that we choose? So based on different kind of data, different kind of objective, we are choosing the model for building the final model, predictive model for that. Okay, fine. And the last one, 6 number step, presentation and automation. Yeah, last. So once the model is created, Then we have to present the data and we have to automate the data analysis steps here. See, here model evaluation comes. We use different techniques, different methods by which we evaluate the model. We are going to evaluate the model, and once the model is evaluated, after that we can deploy the model. Now see, there are some methods called as confusion matrix, which is used for evaluating the classification systems, whether it is text classification or image classification. Confusion matrix is used. Or when regression methods are there, they are evaluated with the help of mean absolute error, mean squared error, R squared error, basically R2 score we call it as, techniques are used. Or for probabilistic model, we use AUC ROC curve with the help of evaluations possible. For clustering technique, we use Silhouette score with the help of the prediction or accuracy is possible. Evaluation, there are many techniques are there that we are using to evaluate, and these techniques are connected with the cross validation. We have seen the cross validation. Cross validation, we are keeping some data aside, and with the help of this data, we evaluate the model at this particular phase to check that whether the machine learning model or the data science model that we created is perfectly working or not. If you are working on neural network, that is CNN or RNN, CNN or RNN, internally, practically speaking, they are internally having a framework. They are created with the help of framework called as TensorFlow, and with the help of TensorFlow framework, we are having internal ability to find the accuracy at various stages of development in the CNN. Okay, that's the part of study that also we can use. So, but evaluation required. You don't directly create a model done. Before that, we have to identify whether the model is having moderate accuracy or not. Okay, so this method, there are common method that we choose to evaluate the model that you created from the respective data. See the summary of it. What we have done till one more step is there, deployment. See, define the goal first, then you will get the data, then we clean the data, then we enrich here we have preparation, then find the insight, feature selection, visualize it, and then deploy the machine learning model, and finally we iterate. Again, we'll start from the first. See, the final step is called as model deployment. Once the model is created, we are going to deploy this particular model in actual location. Practically how this is done. Now see, all these steps we are done, we have created an object of your machine learning or deep learning model. That object we generally save in the binary format. There are some methods. If you're talking about, we generally work in Python. In Python, there are two techniques. The one is job library, and another is called as pickle. So these two methods are there by which you can save this machine learning model binary, and then we have to create the graphical user interface of the project. And in graphical user interface, we import that particular model. And in graphical user interface, two ways are there by which the model deployment is done. The first way, we can have a desktop application created, and we can have web application created. Fine. For creating a desktop application, we'll be making use of the graphical user interface libraries like tkinter or Qt. tkinter is a default library of Python for GUI, and Qt is can import externally. Okay, that way importing externally, we can design this. And for web application development, we use Flask and Django. Web application, we can use Flask and Django. Flask is the common framework that we use, and Django is a special framework. Maybe if you heard about it. Generally, we prefer for desktop application, tkinter is there, and for web application, we prefer Flask. Easy application is there by which you can deploy machine learning model on the server. You have to import that model when you actually want to build, and you can do the predictive analytics on that. Basically, it's an evolutionary process. Means deployment is done. Again, we'll start from the first. Means every time when new data will come, model will get automatically trained. When new data is coming, model will automatically train. It will get modified somewhat a bit, and then after again will deploy it. Again will import data, again deploy. Continuous process, smart system application process that we call it. Okay. After this particular system is built, it is learning by itself. When it start learning, every time model will get the data, learn, get data, learn, get data, learn. But whatever steps present in between that will also taken, that will also be completed. Cleaning the data, then preparing the data, exploring. Exploring is done for our side only. Feature selection will be done. After that, we create the model, do the predictions, again start from the first. So it's like a revolutionary process. Okay, revolutionary process which is present inside the particular machine learning model that we create over here. This is what exactly we perform the operation of building the data science model with the help of the machine learning systems here. many applications that we are derived. Maybe if you're having some ideas in mind, so we have to take care of all of these steps to perform the operation of building the data science application design. In short, this can say that any data, whatever data you have collected, is having some similarities present in that. That similarities we need to identify. It's a part of practice basically. Once you find a similarity, once you build the model perfectly, then predictive analytics can be easily done in the system. Okay, fine. So that's from my side. If you have any kind of doubts or any kind of questions, so it's open for you.